Have you ever wondered how the universe began and where it's headed? From the Big Bang to distant galaxies, black holes, and mysterious exoplanets, this 10-part cosmic journey will take you across time and space. If you love exploring the wonders of the cosmos, make sure to hit subscribe and like to join our journey beyond the stars. Part 1. The beginning of everything. Every star you see in the night sky is a memory. When you look upward, you're not seeing the present, you're looking into the past, across billions of years of cosmic history. Tonight, we begin the journey through the greatest story ever told, the story of the universe itself. Long before Earth, before the sun, before even the galaxies, there was only silence. Then, 13.8 billion years ago, a great beginning burst forth, what we now call the Big Bang. But it was not an explosion in space, it was the sudden creation of space and time itself. In the first instant, the universe was smaller than an atom, unimaginably hot and dense. Within seconds, it expanded at a speed faster than light, an event called cosmic inflation. Space stretched, carrying with it the seeds of everything that would ever exist. As the young universe cooled, protons and neutrons formed. Then, hydrogen and helium, the simplest elements. For hundreds of thousands of years, the cosmos was a glowing fog of particles, too hot for light to escape. But as it cooled further, atoms formed, and the universe became transparent. For the first time, light could travel freely, and the echo of that moment still surrounds us today as the cosmic microwave background. The early universe was not perfectly smooth. Tiny ripples of density left from inflation caused some regions to gather matter more strongly than others. Over millions of years, gravity pulled these regions together, forming great clouds of gas. These clouds collapsed, igniting the first stars. These were not stars like the ones we see now. They were giants, hundreds of times more massive than our sun, burning furiously, living fast, and dying young. Within their cores, nuclear fusion created heavier elements, carbon, oxygen, iron, the building blocks of life. When these first stars exploded as supernovae, they seeded the universe with the material that would someday form planets, oceans, and living beings. From the darkness, the first galaxies were born. Spirals, ellipticals, and irregular swarms of stars gathered together, each one glowing like an island of light in an ocean of night. Over billions of years, they formed the great cosmic web, vast filaments of galaxies stretching across the universe, separated by enormous voids. In these galaxies, new generations of stars formed, each one building upon the ashes of the ones before. And in one small corner of one galaxy, around one ordinary star, a planet would eventually form, a world of oceans and continents where life would gaze upward and ask how it all began. But for now, in this first part of our story, the universe was still young, filled with the fire of newborn stars, a place of chaos and beauty, growing larger and more mysterious with every passing moment. And so begins our journey, from the birth of time itself, across the ages of galaxies, black holes, and worlds beyond imagination. Part 2. The Dance of Galaxies. The young universe was no longer silent. Stars blazed across the dark, galaxies swirled into being, and gravity began its endless work of shaping the cosmos. If Part 1 was the dawn, then this part is the story of structure, the dance of galaxies across the sea of space. Galaxies are not evenly scattered like grains of sand. Instead, they form a vast cosmic web, with filaments stretching for hundreds of millions of light years. These filaments thread across the universe like glowing veins, connecting clusters of galaxies together. Between them lie the cosmic voids, immense regions almost empty, like great dark caverns of space. Within these clusters, galaxies interact. Some spiral gracefully, their arms curling outward like cosmic whirlpools. Others are elliptical, giant glowing ovals filled with older stars. Some are irregular, torn apart by collisions or shaped by gravitational tides. Galaxies are not static islands. They move, collide, and merge, shaping each other in endless dances that last billions of years. When galaxies collide, it is not like cars crashing on a highway. The space between stars is so vast that they almost never hit directly. Instead, their gravity pulls at one another, distorting shapes, triggering waves of star formation, and sometimes creating entirely new galaxies from the chaos. These collisions are slow ballets, unfolding over hundreds of millions of years. One day, even our own Milky Way galaxy will collide with its neighbor, the Andromeda galaxy. The two are rushing toward each other at more than 100 kilometers per second. In about 4 billion years, they will meet. From Earth, the sky will become extraordinary, Andromeda growing larger and larger until it stretches across the heavens, merging with our own galaxy into a new giant, sometimes called Milkomeda. But long before that distant future, galaxies have already been shaping the universe for billions of years. At their centers lie mysteries. Nearly every galaxy appears to have a supermassive black hole at its heart, millions or even billions of times more massive than the Sun. These black holes anchor galaxies, influencing their growth, and sometimes erupting in spectacular displays of energy. From a distance, galaxies seem eternal, glittering islands of light. Yet within them, stars are constantly born and constantly dying. Giant clouds of hydrogen collapse into new suns, while giant stars explode into supernovae, enriching space with heavy elements. This cycle of birth and death continues endlessly, seeding the cosmos with the material for planets, oceans, and perhaps even life. The universe is vast, but it is not empty. Every point of light in the night sky, every galaxy in the deep field of a telescope is part of this grand cosmic dance, a choreography written by gravity, time, and light itself. And somewhere in that dance, a small spiral galaxy on the edge of a filament, with a quiet star and a fragile blue planet, will one day begin to wonder what it means to be part of this story. Part 3. The Mystery of Black Holes. Among the most haunting objects in the universe are black holes, regions where gravity is so strong that nothing, not even light, can escape. They are invisible, but their influence is everywhere. They bend space, warp time, and serve as cosmic engines of both destruction and creation. The idea of black holes began as theory. In the early 20th century, Einstein's equations of general relativity predicted such objects could exist. At first, many scientists doubted them. How could nature allow a place where physics itself breaks down? Yet over the decades, evidence grew too strong to ignore. There are different kinds of black holes. Some are formed when massive stars exhaust their fuel and collapse under their own weight. These are stellar mass black holes, only a few times more massive than the Sun, but packed into an unimaginably tiny space. Others are the supermassive black holes at the centers of galaxies, millions or even billions times more massive. How they form is still one of astronomy's greatest mysteries. What we do know is that black holes are not simply vacuum cleaners, sucking everything nearby. A planet or star could orbit a black hole safely if it kept its distance, just as Earth orbits the Sun. But cross the event horizon, the invisible boundary where escape is impossible, and you are gone forever. The most bizarre aspect is what happens near this horizon. Time itself slows down. To a distant observer, anything falling in seems to freeze at the edge, stretched and dimmed by gravity. But for the object falling in, time flows normally until it reaches the point of no return. What lies beyond remains unknowable. In 2019, humanity caught its first true glimpse of a black hole. The Event Horizon Telescope combined data from observatories around the globe to produce an image of the shadow of a supermassive black hole in the galaxy M87. It looked like a glowing orange ring, warped light surrounding a dark heart. For the first time, what was once only theory became visible. Black holes also fuel some of the brightest objects in the cosmos. As matter swirls into them, it forms accretion disks, hot, glowing rings of gas spiraling inward. Some black holes shoot out enormous jets of energy, stretching for thousands of light years, visible across the universe. In a strange twist, these destroyers help shape galaxies, regulate star formation, and spread heavy elements into space. There are even more exotic possibilities. Some scientists suggest that black holes could connect to other regions of space-time, wormholes, theoretical bridges that might link distant parts of the universe. Others wonder whether black holes could play a role in the birth of new universes. These ideas remain speculative, but they remind us how much we still don't know. What is certain is this: black holes are not simply cosmic voids. They are fundamental to the universe, sculpting galaxies, challenging our understanding of physics, and hinting at deeper truths. They stand at the edge of knowledge, daring us to look closer. And yet, as terrifying as they seem, without them, the universe might not look the way it does today. They're part of the cosmic balance, the shadows that allow light to shine. Part 4. The birth and death of stars. Every star in the night sky tells a story, not just of shining light, but of a journey billions of years long. Stars are born, live vibrant lives, and eventually die, sometimes quietly, sometimes in spectacular explosions that reshape the universe itself. Stars begin in the cold, dark clouds of gas and dust that drift between galaxies. Inside these vast nebulae, gravity slowly gathers matter together. Denser regions collapse, growing hotter and brighter, until at last a spark ignites. Nuclear fusion begins, and a star is born. Fusion is the heart of a star's power. Hydrogen atoms fuse into helium, releasing enormous amounts of energy. That energy pushes outward, balancing the crushing force of gravity pulling inward. This balance allows stars like our Sun to shine steadily for billions of years. Without fusion, the universe would be cold and dark. But stars are not eternal. Their fate depends on their size. Small stars, like red dwarfs, burn slowly and can live for trillions of years. They are the quiet keepers of the cosmos, glowing gently across time. Medium stars, like the Sun, eventually run out of hydrogen fuel. They swell into red giants, shedding their outer layers into space, leaving behind a small, dense core, a white dwarf that slowly cools. The most massive stars face a far more dramatic ending. When their fuel is gone, they collapse violently, triggering a supernova, one of the most powerful explosions in the universe. For a brief moment, a single star can outshine an entire galaxy. These explosions scatter heavy elements, iron, gold, carbon, across space. Every atom in your body, heavier than hydrogen and helium, was forged in a star and released in such a death. You are, quite literally, made of stardust. Sometimes, the collapse after a supernova is so extreme that a star becomes a neutron star, a city-sized sphere of matter so dense that a teaspoon would weigh billions of tons. Some neutron stars spin rapidly, sending out beams of radiation we detect as pulsars. Others, even heavier, collapse further into the ultimate mystery, a black hole. Star birth and star death are not just isolated events. They are part of a cosmic cycle. The gas and dust released by dying stars enrich nebulae, providing the raw materials for new stars, new planets, and perhaps new life. The universe recycles itself endlessly, building worlds from the ashes of the old. When you look up at the night sky, every point of light is not just a star, it is a story in progress. Some may already have died, their light only now reaching us after traveling across unimaginable distances. Others are still being born in hidden clouds of gas we cannot yet see. The heavens are alive, always changing, always renewing. The stars remind us of two truths. Nothing lasts forever, and yet nothing is truly lost. Their deaths create the possibility of new beginnings. Out there in the dark, the universe is always writing its next chapter in fire and light. Part 5. The Search for Exoplanets. For most of human history, the question, "Are we alone?" was pure speculation. We knew of only one planet with life, Earth. But in the past few decades, a revolution has unfolded. Astronomers have discovered thousands of exoplanets, worlds orbiting stars beyond our sun. And with each discovery, the possibility of other Earth-like planets grows stronger. The first confirmed exoplanet around a sun-like star was found in 1995, 51 Pegasi b, a giant world orbiting so close to its star that its year lasts just 4 Earth days. This discovery stunned scientists. It didn't look like anything in our own solar system, and it showed that planetary systems could be stranger than we had ever imagined. Since then, technology has transformed our ability to detect these distant worlds. The Kepler Space Telescope, launched in 2009, monitored the brightness of over 150,000 stars, looking for tiny dips in light when a planet crossed in front, a method called the transit method. Kepler alone found over 2,600 confirmed planets, from scorching hot giants to small rocky worlds not much bigger than Earth. Today, new observatories like TESS, or Transiting Exoplanet Survey Satellite, and James Webb Space Telescope, or JWST, are taking the search further. JWST, with its powerful infrared vision, can analyze the atmospheres of exoplanets, searching for chemical fingerprints such as water vapor, carbon dioxide, and perhaps, one day, signs of biology. One of the most exciting discoveries has been the TRAPPIST-1 system, just 40 light-years away. It hosts 7 Earth-sized planets, 3 of which lie in the habitable zone, the region where liquid water could exist. Imagine standing on the surface of one world and seeing 6 others hanging in the sky, close enough to appear larger than our moon does from Earth. Not all exoplanets are Earth-like. Some are hot Jupiters, massive gas giants hugging their stars. Others are super-Earths, rocky planets larger than Earth but smaller than Neptune. There are worlds of endless storms, scorched surfaces of molten rock, and frozen orbs locked in eternal darkness. The diversity is staggering. Yet somewhere among these thousands, perhaps millions of planets, there may be one truly like our own. Oceans, clouds, continents, and the possibility of life. For now, we cannot visit these worlds. They're too far, separated by light years of empty space. But with every discovery, we are mapping the possibilities. Each exoplanet is a hint that the universe is not just stars and galaxies. It is also a universe of worlds, some familiar, some utterly alien. As you look up at the stars tonight, remember, around many of them, unseen planets are circling, silent and distant. Some may be barren, some may be beautiful, and perhaps on one of them, someone might be asking the same question we do. Are we alone? Part 6. The Expanding Universe. In the early 20th century, most scientists believed the universe was static, eternal, unchanging, infinite. But in 1929, astronomer Edwin Hubble made a discovery that would rewrite our understanding of everything. Galaxies are moving away from us, and the farther they are, the faster they recede. The universe itself is expanding. This revelation meant that the cosmos had a beginning. If everything is spreading out now, then in the past, it must have been closer together. Extrapolated backward, this leads to the idea of the Big Bang, the moment, about 13.8 billion years ago, when the universe burst into existence from a hot, dense state. At first, the Big Bang was controversial. Many doubted it, preferring the idea of a steady, eternal universe. But in the 1960s, scientists discovered the cosmic microwave background, a faint glow of radiation spread across the entire sky. This ancient light is the afterglow of the Big Bang, a direct fingerprint of the universe's fiery birth. Expansion did not stop there. In the late 1990s, another shocking discovery shook cosmology. The universe isn't just expanding, it's accelerating. Distant supernova observations showed galaxies moving apart faster and faster, as if some unseen force is pushing them. Scientists call it dark energy, but what it really is remains one of the greatest mysteries of modern science. If dark energy continues, the universe will grow emptier over time. Galaxies will drift farther apart until their light no longer reaches one another. Stars will burn out, and only black holes and cold remnants will remain. Far in the future, even those black holes may evaporate, leaving a universe of silence and darkness. But the story is not all bleak. The fact that we live in this moment, when galaxies still shine, when stars are still being born, when life exists, makes our era uniquely precious. We live at a cosmic dawn, able to look back to the birth of time and forward to its distant faith. And though expansion may seem abstract, you can see it in the night sky. Every galaxy you glimpse through a telescope is on its own path outward, carried by the stretching of space itself. The cosmos is not static, it is alive, restless, and moving. The expanding universe is a reminder that nothing stays the same forever. From the tiniest atoms to the largest structures, everything changes. And in that change lies both mystery and beauty, the eternal unfolding of a story bigger than all of us. Part 7. Dark Matter and the Invisible Universe. When we look at the stars and galaxies, it's easy to believe we're seeing the whole picture of the universe. But astonishingly, everything we can observe, stars, planets, gas, and dust, makes up less than 5% of the cosmos. The rest is hidden, invisible, yet its presence shapes everything. One of the great mysteries is dark matter. It does not shine, absorb, or reflect light, making it invisible to telescopes. Yet we know it must exist because of its gravity. In the 1930s, astronomer Fritz Zwicky noticed that galaxies in a cluster were moving too fast to be held together by visible matter alone. Something unseen was providing the extra pull. Decades later, Vera Rubin confirmed this on a galactic scale. When she measured how stars rotated around the center of galaxies, she expected stars on the edges to move more slowly, like planets in our solar system. Instead, they move just as fast as stars near the center, as if an enormous halo of invisible mass was holding the galaxy together. That invisible mass is what we now call dark matter. It outweighs ordinary matter by 5 to 1. Without it, galaxies would fly apart and the universe would look nothing like it does today. Dark matter acts as the scaffolding of the cosmos, pulling matter together and shaping the grand structures we see across billions of light years. What is dark matter made of? That remains unknown. Some theories suggest it could be exotic particles beyond anything we've ever detected. Others imagine faint, undetectable objects, or even entirely new laws of physics. Despite decades of experiments, deep underground and in space, dark matter has never been directly observed. Even more mysterious is dark energy, the force driving the universe's accelerating expansion. Together, dark matter and dark energy make up 95% of everything. Yet we understand almost nothing about them. It is as though we are staring at a puzzle where nearly all the pieces are missing. Still, the mystery itself is thrilling. It means the universe is not yet fully revealed. Behind the stars we see lies a hidden realm, one that holds the secrets to why galaxies exist, why the universe evolves the way it does, and perhaps why we are here. Every time you gaze into the night sky, remember, most of what surrounds us is invisible. But invisibility does not mean unimportance. In fact, it is the unseen that holds everything together. Part 8. The Fate of the Universe. If the universe had a beginning, it must also have an ending. For centuries, humans have wondered not only where we come from, but also where we are going. Thanks to modern cosmology, we now have glimpses of possible futures, though the final answer is still uncertain. The universe is expanding, driven by the mysterious force of dark energy. But what will happen billions or trillions of years from now depends on how that expansion behaves. Scientists consider several scenarios. One possibility is the Big Freeze. If dark energy remains constant, the universe will keep expanding forever. Galaxies will drift farther apart until their light can no longer reach each other. Stars will burn out and new ones will stop forming. Over unimaginable timescales, the cosmos will grow dark, cold, and empty. Black holes will evaporate, and all that remains will be a thin haze of particles in eternal night. Another scenario is the Big Crunch. If gravity someday overcomes dark energy, the expansion could slow and reverse. Galaxies would fall back together, stars and planets collapsing into a final fiery implosion. The universe would end as it began, in heat and density, perhaps even giving rise to a new Big Bang. Then there is the most dramatic idea, the Big Rip. If dark energy grows stronger with time, expansion will accelerate so violently that galaxies, stars, planets, and eventually even atoms will be torn apart. The very fabric of space-time would unravel in a cosmic catastrophe. There are even more exotic possibilities. Some physicists wonder if our universe might tunnel into a new state of physics, collapsing in a sudden transformation. Others suggest that new universes may constantly butt off from our own in a grand multiverse, making our cosmos just one chapter in an endless book. For now, we cannot know which fate awaits. But what we do know is that we live in a very special era, one where stars still shine, galaxies still glow, and life exists. In the grand timeline of the cosmos, this moment is fleeting, but it is ours. When you look up at the night sky, you are not just seeing the past, you are also glimpsing the universe's future. The stars remind us that even in endings, there are beginnings. The cosmos has been reborn before, and perhaps it will be reborn again. The fate of the universe may be uncertain, but one truth remains. Existence itself is a miracle. That we can ask these questions at all is proof that the universe has, at least for now, given us the gift of wonder. Part 9. Human Exploration of Space. For as long as we have gazed at the stars, we have dreamed of reaching them. Human exploration of space is one of the greatest stories of our species, a tale of courage, ingenuity, and the eternal desire to go beyond the horizon. The journey began in the mid-20th century, during the space race. In 1957, the Soviet Union launched Sputnik 1, the first artificial satellite into orbit. Just 4 years later, in 1961, Yuri Gagarin became the first human to travel into space, circling Earth in a single orbit. His words, "I see Earth, it is so beautiful," captured the awe of a new age. The United States soon followed, setting its sights on the moon. In 1969, Apollo 11 achieved the impossible. Neil Armstrong and Buzz Aldrin walked on the lunar surface, leaving footprints that still remain today. For the first time, humanity had left its home world and set foot on another. Since then, space exploration has expanded beyond national rivalry. Space stations like Mir and later the International Space Station, ISS, became laboratories in orbit where astronauts from many countries live and work together. The ISS has been continuously inhabited since the year 2000, making it a symbol of human cooperation in the vastness of space. Robotic missions have gone even farther. The Voyager probes, launched in 1977, are now traveling through interstellar space, carrying golden records with sounds and images of Earth. Rovers like Curiosity and Perseverance explore Mars, searching for signs of ancient life. Space telescopes like Hubble and James Webb peer deep into the cosmos, showing us galaxies billions of light years away. And the journey is far from over. Humans are preparing to return to the moon through NASA's Artemis program, building a gateway that may serve as a stepping stone to Mars. Private companies are pushing the boundaries of reusable rockets, dreaming of colonies on other planets. Space exploration is not just about discovery. It also gives us perspective. From orbit, astronauts describe the overview effect, the profound realization of Earth's fragility when seen as a small blue sphere against the darkness. Borders vanish, conflicts fade, and only one truth remains. We are all passengers on this same tiny world. One day, we may walk on Mars, sail the icy oceans of Europa, or even voyage to other stars. Each step outward begins with a dream, the same dream that has guided us since the first humans looked up at the night sky. We explore because it is part of who we are, to understand, to seek, to go beyond. The universe is vast, but so is our curiosity. Part 10. The Future of Space and Humanity. The universe stretches farther than the eye can see, filled with galaxies, stars, and mysteries yet to be discovered. But humanity's story is just beginning. In the coming centuries, we may leave Earth behind, spreading across the solar system and perhaps even beyond. Colonies on the Moon and Mars may become reality. Scientists are already studying terraforming, ways to create habitable conditions on other worlds. Spacecraft powered by nuclear or fusion engines could make interstellar travel feasible, allowing humans to visit distant star systems in decades rather than millennia. Beyond exploration, space holds the promise of knowledge and survival. Our planet faces natural and human-made risks. By expanding into space, we reduce the chance that a single catastrophe could end humanity. In a sense, the stars are not just objects of wonder, they are insurance for life itself. But the future is not only practical, it is also poetic. Imagine generations of humans looking up at alien suns, composing art under unfamiliar skies, and discovering life elsewhere. Perhaps one day we will meet intelligent beings, beings who gaze at their night skies and wonder just as we do. Technology will grow, enabling us to harness the energy of entire stars through Dyson spheres, or even manipulate the very fabric of space-time. Black holes and wormholes, once purely theoretical, could become bridges across the cosmos. And yet, for all our ambition, the universe will remain infinitely mysterious. As we move outward, humanity will carry something unique: the ability to reflect, to dream, to ask questions. The universe is immense, but so is our imagination. Every discovery will bring new questions, and every journey will bring awe. So, as this story ends, remember, the universe is not just out there. It is within us, in our curiosity, our courage, and our desire to understand. From the first stars to the distant future, from black holes to unknown worlds, the cosmos is a story, and we are part of it. Look up tonight. Every twinkle is a whisper from the past, a promise of the future, and an invitation to wonder. Humanity's journey through space has only just begun, and the story of the universe continues, written in light and shadow across the vast, eternal night.